This screencast is going to discuss how to calculate empirical and molecular formulas. So let's say we have a compound. We have a compound and we want to analyze its composition, its percent composition. We can put it in a machine and it will spit out the percent composition, but it won't tell us exactly what the formula will be. So we can do a calculation. And in terms of how I would start to calculate it, we can do a few things. So this is actually a poem that I learned from my high school teacher. First step is to get the percent, go to mass. Then I have a few notes here. Then the next step is to get that mass and convert it to moles. And then within all the moles, you look for the smallest number of moles and you divide all the moles by the smallest number. And then if you have a fraction of some type, you can multiply everything until you get a whole number. So the way that this poem reads is you go from percent to mass, mass to mole, divide by small, multiply till whole. And I'll show you with example number 17. So we'll skip this section for now. So for number 17, it says, determine the empirical formula if a compound is made out of 43.64% phosphorus and 56.36% oxygen. So right now they gave us the percentages. So for the percentages, I'm trying to color code this, percentages, I'm going to convert that to mass. We don't always have to have it if they already give us the mass, but in this case they didn't. They give us percentages. So I'm going to assume I have 100 grams. If I have 100 grams of my substance and 43.64% is phosphorus, that means I have 43.64 grams of phosphorus. And same thing goes with my oxygen. I have 56.36% grams of oxygen. Okay, so I just did step one right here. So this is my step one. I took my percent, okay, my percentage is here, and I converted it to mass by assuming I have 100 grams. Then my next step, step two, is I'm going to take all my masses and convert them to moles. So I'm going to do a multiplication sign for both. And then if I want to convert to molar mass, I would have to look at the periodic table. And if I were to look at the periodic table, looking at the molar mass of phosphorus, you get 30.97 grams of phosphorus, and then I would put 1 mole of phosphorus on top. Do the same thing with oxygen. So with oxygen, it's 1 mole of oxygen on top, and then 16.00, or you could just write 16 grams. Then I stop here for my step two. So this is my step two in blue square. I will punch this in my calculator, and here it says don't round yet. So I'm going to leave many digits, as many as I can. I'm going to do 1.409105. For the oxygen one, I get 3.5225. And all these numbers, these are the mole ratios. So this is this many moles of phosphorus to this many moles of oxygen. But here, these ratios aren't in a whole number ratio, so we're going to try to get to that point by completing step three. So step three, it says divide all the moles by the smallest numbers. Okay, so if I look between 1.4 versus 3.5, 1.4 is the smallest number. So I'm going to divide. So this is my third step. I'm going to divide both of them by the smallest number. I'm dividing both of them by 1.409105. The reason I want to do that is because if I divide all of my moles by the smallest number, that smallest number one results in 1 mole of phosphorus. So it's like a nice, easy number. If I do 3.55 divided by 1.409 in my calculator, I get 2.4998. Okay, so here it says you can round, but only when it's like really close to the next number, and then or if it's really close to a half. So right here, this 2.4998 is so close to 2.5, I can round it to 2.5. So this is saying for every 1 mole of phosphorus, I have 2.5 moles of oxygen. So if I were to kind of think about like the formula, this isn't the correct answer yet, but the formula like would be 1 phosphorus to every 2.5 parts of oxygen. So normally when we're writing formulas, it's always in whole number ratios. So this isn't the final answer yet. I'm going to do step 4, multiply till whole. So here it says it's not always needed. If I had an answer of like 1 and 2, I would be done. It would be P1O2. But because I have a fraction right here, I'm going to multiply until whole. So I'm going to multiply both of them by a factor to get me a whole number. And if you think about this, you would multiply it by 2. So once you multiply it by 2, I have 2 moles of phosphorus for every 5 moles of oxygen. Okay, so finally, I can arrive at my final answer, and my final answer will be the empirical formula is equal to P2O5. And then I'll also have you box your final answer. The rest of the examples I'll show on another screencast.